Hi everybody, this is Craig Robertson through Innovation Plaza at UNM in the Electrical and Computer Engineering building. I want to give you an overview of minterms. This will kind of build off the binary number counting, the binary to decimal conversions that I've covered in other videos, but it'll help you with a basis for understanding the way we set up truth tables and the way we set up K-maps, and just what minterms actually are and what they mean. So I'm going to go ahead and set up a 3-variable truth table for you, and the variables will be A, B, and C. And I'm going to go ahead and say that we're going to have a function out from this that will be F. So I'm going to set up this truth table with 4 zeros, 4 ones in the first column, 2 zeros, 2 ones, 2 zeros, 2 ones, and then just alternating every other here. Now this may seem like kind of a funny little pattern. Some of you may want to set it up the other way, depending on your experience from linear algebra. But we actually like to do it this way in computer logic because it sets up our minterms for us. Now we can say that minterms, little m, is the decimal equivalent of these three numbers. So I'm going to go ahead and call this one. I'm going to point out that this here is the most significant bit, and this here is the least significant bit. So this would be 2 to the 0 place, 2 to the 1's place, and then 2 to the 2's place. So let's go ahead and set these up. This would be our minterm column. I'm not going to put zeros and ones here. I'm just going to label the minterms. So what a minterm is it's the decimal representation of your inputs from most significant to least significant bit. So I'm going to go ahead and show you this. So at 0, 0, 0, the binary conversion of 0, 0, 0 is decimal 0, right? It's just all zeros. So we're going to go ahead and call this minterm 0. Now, the binary conversion of 0, 0, 1 is 1. So we're going to go ahead and call this minterm 1. You see how this is just changing it from binary into a decimal conversion for your minterm. So let's go ahead and do 0, 1, 0. Well, I know that the 2 to the 0 place is a 0. The 2 to the 1 place is a 1, so that's going to be 2. And then the 2 to the 2 place is 0. So this all totaled up is going to be equal to minterm 2. Now I think you can see sort of a pattern starting here, is that really we're just counting from 0 to 7 in binary. Notice that we do 0 index. If you programmed in C, that's very important to 0 index everything. So let's go ahead and fill out the rest of these. If you do the math and the conversions, which is good practice, it'll help you out and it'll prove it to you. So basically this is how you set up a minterm in a truth table. It's if you number your truth table correctly, this will give you all the possible combinations for your inputs, and you can label your outputs by places. Now this is helpful when we do a K-map. So a K-map, whereas this is a table representation of our truth value, a K-map is just a graphical representation of our truth value. So let's go ahead and I'll call this one A down here and then B, C up here. So I'll go ahead and set the K-map up like that. Now if A is a 0 for this row and A is a 1 for this row, that's how I want to index it. So what I'm doing is I'm saying when A is a 0, we're going to be in this row. When A is a 1, we're going to be in this row. You see how it's just kind of graphically laying out what I've done in the table here? This will help us simplify. So let's go ahead and say, since we have 2 up here, B and C, I'm going to start with 0, 0, 0, 1, and then here's kind of a curveball. It goes 1, 1, and then 1, 0. what I want to do here is I want to scale this like gray code. And I want to make this 0, 0. And do you see from this column to this column how only one bit changes? 0, 1. And then from this column to this column only one bit changes, right? 0, 1. Then from this column to this column only one bit changes. 1, 0. That'll allow us to put everything that has a bit in common right next to each other. So this will aid us in simplification. If you label this K-map the incorrect way, it'll go 0, 1, 2, 3, right? But we don't want to do that, because then all of your loops and your circles will be, when you simplify with your K-map, they'll just be nonsense. It won't tell you anything. And you'll probably get marked off on that problem. So what I want to show you is if we do this the same way, if we count these minterms out the same way, and I'm going to do all of them this time because it's a little rearranged because of this column. But if we count these minterms out, we can see how they directly map from our truth table to our K-map. So let's go ahead and do this. So if A is a 0, B is a 0, and C is a 0, well, that corresponds to this term right here, 0, 0, 0. So this right here would be minterm 0. 0, 0, 1 would correspond to this term, 0, 0, 1. That would be minterm 1. Now here's kind of a curveball when you do the K-maps. They're just a little rearranged, so make sure you pay close attention to this. 0, 1, 1. Notice how that is not minterm 2. That's 0, 1, 0. We're looking for 0, 1, 1. So that'll give us 0, 1, 1. This is actually minterm 3. So let's go to 0, 1, 0. 0, 1, 0. This one over here is actually minterm 2. Now let's go ahead and go to the second row. 0, or I'm sorry, 1, 0, 0. So 1, 0, 0 corresponds to minterm 4. Now let's correspond to the next one. So let's go 1, 0, 1. So 1, 0, 1 means that this block here is minterm 5. And then we start 1, 1, 1. Well, that's down here. That's 1, 1, 1. Notice that it's not 6 because we've rearranged these numbers here. It's 1, 1, 1 is minterm 7, so that corresponds to minterm 7, right? 1, 1, 0 corresponds to this number, 1, 1, 0, which is actually minterm 6. So you see both of these, truth tables and K-maps, are just different ways of representing the exact same configuration. Now, some of you may like truth tables better. I find it's easier to map or to do a truth table for very complex equations and then move them into a K-map. But a lot of people, when they can just kind of visualize the equation, or when they're just given a list of minterms, go straight to a K-map, skip the truth table altogether, and save themselves about 5 minutes on the test, which can decide whether you get an 80 or a 90 on it. So that's a good minterm overview. I'll do the same for max terms. It's not all that different. It's just like to dispel kind of the myth. Anyway, this is Craig Robertson with Innovation Plaza. I hope you feel like I simplified this a little bit for you. If you have any questions, come and see us in room 312 in the ECE building. We're open usually every weekday, and there's almost always somebody in there who can help you out with this kind of stuff. But yeah, come by and drop by and see us, and good luck with your studies.